Coolant is circulated by the integrally mounted water pump. The output from the water pump empties into the oil cooler cavity of the cylinder block. This provides the oil cooler with the coolest possible coolant. From the oil cooler cavity, the coolant flows into the lower water manifold. From the lower water manifold, the coolant enters the water jacket cavity. Coolant travels around the liners, carrying combustion heat to the top of the block. Coolant flowing through the single passage per cylinder in the right side of the cylinder head gasket flows to the lower water cavity through drillings in the cylinder head. This flow cools the valve seat and injector area. This coolant continues its flow into the upper cavity of the cylinder head. Coolant flowing through the 2 passages per cylinder in the left side of the cylinder head gasket flows to the upper water cavity in the cylinder head, crosses over the valve seats and bridges. The coolant in the lower water jacket in the cylinder head connects to the upper water jacket through a series of passages in the cylinder head. The coolant then flows across the cylinder head, down into the upper water manifold in the engine block, and then forward to the integral thermostat housing. When the engine is below 82 degrees centigrade, the thermostat is closed, allowing the coolant to bypass the radiator and flow back to the water pump inlet through an internal drilling in the cylinder block. As the coolant temperature increases to 82 degrees centigrade, the thermostat starts to open, and coolant flow to the bypass begins to be restricted. When the engine operating temperature increases to 91 degrees centigrade, the thermostat completely opens, blocking the bypass passage to the water pump and opening the outlet to the radiator. The engine must never be operated without a thermostat. Without a thermostat, the coolant recirculates, bypassing the radiator, causing the engine to overheat. With a positive flow deaerating cooling system, water supply to the inlet side of the water pump is supplied by 3 sources: the bypass passage, the bottom tank of the radiator, and from the fill line. When the thermostat is closed, the pressure in the block circuit causes the supply to the water pump to flow from the bypass passage. When the engine reaches operating temperature and the thermostat opens, the pressure in that part of the circuit causes the flow to come from the bottom tank of the radiator. The fill line ensures that there is a positive flow of coolant at the water pump inlet at all times. As the water pump increases in speed, more coolant is needed to increase the coolant flow. When the block and radiator circuit cannot supply enough coolant, the low pressure at the pump draws coolant through the fill line. When equipped with a coolant filter, a portion of the coolant flows through the coolant filter mounted on the right side of the engine. The filter head can be mounted in either a rear mount or mid-mount position on the mounting pad shown here. The coolant filter helps to maintain the proper additive level in the cooling system and should be changed at the appropriate maintenance interval. The higher pressure coolant in the lower manifold pushes the coolant through the filter. After passing through the filter, the coolant returns to the lower pressure upper manifold. The orifices in the cylinder head gasket provides the pressure differential in the upper and lower manifold to force flow through the filter. The air compressor receives coolant through a line connected to a fitting in the cylinder block near cylinder number 5. Coolant travels to the air compressor cylinder head to cool the compressor. From the compressor, an external line directs the coolant back to the engine cylinder head. On engines utilizing a VG turbo, coolant from the lower water manifold flows through external plumbing to the variable geometry turbocharger housing. The turbocharger housing is water-cooled to prevent overheating of the seals on the nozzle ring linkage. Coolant from the turbo is returned to the upper water manifold in the block. The pressure difference between the lower and upper water manifolds ensures a continuous flow of coolant to the turbo. Some industrial versions of these engines utilize a water jacket aftercooler installed on the engine. This aftercooler receives its coolant supply through an external line plumbed to an opening in the lower water manifold cavity at the rear of the block. Coolant flows from the aftercooler to the upper water manifold cavity at the rear of the block.